Welcome everyone to Sydney.NET User Group. Today, I'm going to talk about how we can build an enterprise-level microservice solution with Ocelot on Azure. My name is Patrick Zhao. Over the years, I get asked by my clients to build microservices of all sorts. Look, building microservice can be fun and enjoyable most of the time, but sometimes it can be pain, especially if not done properly. Today, I'm going to show you how we use a library called Ocelot and build our microservice solution quick and easy and deploy on Azure. Now, for most of you watching today's video, you might not have heard of Ocelot before. But look at this lovely Ocelot. It has got a set of blue eyes. What does it remind you of? It reminds me of Azure. And they together would help us to build our microservices easily. Before we get started, I'd like to draw your attention to this SSW Rewards app. We have a bit of gamification with it that you can accumulate some rewards points by joining our talk and scanning the QR code that I'll show you shortly. And you can get some gifts. For instance, an SSW bottles and the Mi bands and etc. So don't remember to scan them. All right, a little bit further about myself. I'm a solution architect at SSW, and I enjoy doing public speaking in my spare time and share my opinions and ideas with all the others in the tech community. I do Azure, and I enjoy DevOps and data and bot framework. Here is my Twitter. If you want to be a bit formal, there's my LinkedIn and my profile page on SSW people site. At SSW, each consultant has got his own profile. You can easily find me by Googling Patrick Zhao. And as other developers, in my spare time, I enjoy contributing to some of the open source projects and following other great open source projects on GitHub. My recent interest has been SophieBot. We use Microsoft Bot Framework to build a conversational AI chatbot that can be used as a virtual receptionist. So imagine you have a guest coming to your building to visit some employee in your organization. Traditionally, you need to have a reception sitting on the front desk and help making an appointment or checking who's available and when. Now, with SophieBot, what you can do instead is the guest will chat with a bot as if they are chatting with a real human, and they can identify and find an employee of certain skill sets and availability. Come and check out my GitHub activity if you have a common interest on it. And at last, I have my personal blog. I see it's a great place for me to retrospectively summarize the project I've been recently working on and the lessons I've learned, the new tech, and etc. All right, so here's today's agenda. First of all, let's look at Monolith versus microservice. As two different software architecture, what are the pros and cons of each of them? And then we were going to have a deep dive into microservice area and find out what are the key components, what are the benefits, and what are the challenges and potential traps in building your microservice. And then we're going to narrow down further to put our eyesight on Azure and see how and which kind of services we can leverage to deploy your microservice on Azure. And as always, I've got a demo to show you a proof of concept of building an API gateway and deploy it on Azure with a bunch of microservices and some techniques to protect your microservices on Azure. Now, let's get started. So what is Monolith? You must have heard of this term, but what is the exact definition of it? Doesn't mean that a bunch of Lego bricks that's completely spread out everywhere, disorganized chaos? Actually, not. A monolith architecture is actually a quite unified and easy to understand architecture, by which it means it has a unified interface starting from the bottom. As we can see in this diagram, there's a browser there. So as a user interface, the user interacts with that layer and only with that layer. And then upwards, the presentation layer is going to interact with there's an interface layer. Basically, if we talk about web app, this is the APIs that you've got. And then that layer is going to upwards only interact with the business logic layer. And further on, the data access layer, which potentially is some kind of ORM like EF or other ORMs, and then run CRUD operations or whatever analytics you need to run on your data store. And then, as a round trip, it's going to backwards communicate with the layer up and all the way send a response to the browser. So as we can see, in this transaction script architecture, everything is straightforward and one way. And of course, it's a return trip. So what that means is that it's actually easy to understand and simple to build. However, does it come with any problem? So let's look at the pros and cons. First of all, a monolith solution is most of the time self-contained, by which I mean, once a big giant solution, you can have tens of thousands or millions lines of code. But once that solution is built, the artifact, and in .NET world we have DLL, is self-contained, meaning you can deploy that solution to an environment and only one environment that you have to look after. Of course, you can have staging and etc., different environment, but they are all self-contained. You only have one set of artifacts you need to deploy. That means it's easier to maintain from the hosting environment's perspective. And of course, it's easy to test and debug. Here, the assumption is that we are only talking about a black box test. We treat the entire monolith solution as a black box, and then we feed it with some sort of input via the presentation layer, and we assert on the response it's sent back. And of course, there's less overhead in cross-module communication. What that means is, usually, if you have some shared code in your monolith architecture that other bits and pieces need to reference, you just call them directly, like a class library. There's no network traffic going on. There's no overhead. It's just calling the code directly. And it's easy. Actually, it's the easiest way to start a new project or a proof of concept, because there's almost no overhead or scaffolding you need to do. You kickstart straight away. Now we've looked at the upside. Let's look at the flip side. What are the cons? So first of all, if it's not done right, it's very easy to be tightly coupled. Here, look at the start there. There's the other one, which can potentially go wrong, is that it tend too hard to update individual features if those features are coupled with each other. So the other risk is it can be avoided if we follow a modular approach. What that means is we're gonna have a clear boundary of different pieces in your code, and each of them is served as a module. And that way, the module can be pluggable. So that can solve some of the problems that were listed here. However, there's a hard roadblock. The first one is the massive code base in a single repository, because that's the essence of a monolith architecture. What that means is whenever any new developers need to come on board to join the dev team, they need to be trained to understand the entire solution. only when they have a certain amount of understanding at a holistic level, they can start working on a small piece. So that makes the productivity low. And the scaling is also holistic. You can either scale the entire solution or not scale it. And it will incur some unnecessary costs if it's not done properly. Okay, so we've talked about the pros and cons of Monolith. Let's look at how or under what circumstance we're going to consider to move a solution from Monolith to microservice. Usually it happens when we want to do a big legacy system upgrade, especially when we try to upgrade the tech stack of a big legacy system. There's a famous software or architectural pattern called strength-fig pattern, in which we don't upgrade the entire solution in one go, big bang, but we work out a business unit of different modules, and then we create those modules in microservice and slowly migrate them across from the old system to the new system. In the meantime, we can keep the old system running in parallel so that you don't lose any running features. And when we want to consider the application scalability, microservices might be a good choice, especially when you want to scale up or scale out different pieces in your entire solution. Then the productivity, as I mentioned in the previous slide, is also one of the consideration if we want to bring in microservice architecture. Mind you, microservice architecture is not just a software architecture, but it's also a methodology, how we run the development team. If we are following a microservice architecture, what it tends to happen is you're going to have a smaller team, Scrum teams, looking after each individual microservices. And they can collaborate closely, and it's easier to onboard new team members. So if we take this Rubik cube, well, this is not a Rubik cube. When we look at the Monolith, it's just one piece. But if we start to have a modular approach, what we're going to have is a Rubik cube where we have a boundary between different bits and pieces in the system. However, we cannot take any one of the little cube out. Otherwise, the entire the Rubik cube is going to fall apart. But once we have a microservice architecture, as we can see that we can transform from a modular monolith architecture to a microservice architecture quite easily. Once we've got a boundary there, we just need to make sure that each Lego brick on the microservice Rubik cube can be replaced and can be removed and re-added easily. Now, we've had an overview of what is the microservice architecture and what is the benefits of it against the traditional monolith architecture. Let's look at some details of microservice architecture. First of all, we need to look at the key components which compose your microservice solution. The first thing comes up is the API gateway. It serves not only as the single point of entry, but sometimes it can serve as a coordination or orchestration point of your subsequent services. We want to be able to support different types of front ends, either a web app or desktop app or mobile, whatever. And we want to leverage containerization techniques to make sure that our microservices are easy to test and to deploy, and to roll back in production. Here I put Docker there. Certainly there are other containerization skills, but I love Docker. And each microservice is in charge of its own data store. This single data store principle is very important, and it can be confusing sometimes. Here, the keyword is data store instead of database. One microservice can own a part of database or a schema or a couple of tables. It doesn't have to own the entire database. However, a service should not touch the other services data store without communicating with the other database. Without communicating with the other service. So that way, each microservice has its own data store and it's in charge of it. The cross-service communication is done between services, but not between databases. Data stores. Here, you can see that I sometimes get it wrong. A microservice owns a data store, not a database. And most of the time when we build our microservices, we want to follow event-driven architecture or event-driven pattern. And I like to put a VNet around my microservice, which protects it from being accessed or being hacked by a public external world. And the communication between my microservices can be done on the barebone network provided by my hosting provider. And in Azure, it's all via Azure network, which is secure and solid. And there need to be some messaging system to support our event-driven pattern so that the communication between microservices does not only go via the normal REST or HTTP call, but can leverage some pub/sub service, which can enable you to build up a different mechanism, such as rewinding or replying of some of the messages. Now let's look at the, we've understood the key components. Let's look at the few of the deployment options. First of all, as a Monolith solution or Monolith architecture, we can leverage any platform as a service on public cloud providers. On Azure, we have a web app running on containers, Azure Function, etc. Or we can choose to leverage containerized applications such as Azure Container Instance. And this is something new that came up fairly recently, like I can't remember exactly, but it should be like half a year ago, called Azure Container Apps, which is essentially a serverless container offering. And I want to check it out because this is the first time Azure has done something connecting up serverless and containerization. And you can always choose to build your own Kubernetes cluster. On Azure, we have AKS, which you can try that out. All right, so we've mentioned about the productivity on your development team. Let's look at some details. So if we use microservice architecture, we tend to have a faster onboarding process, especially with new developers and developers joining a new team. We can quickly adapt to a business requirement change if that business requirement is only sitting on a certain boundary or a certain piece of a business unit. So here's a chart. From it, we can see that if we are following a monolith approach, to begin with, our development speed is really quick because there's less overhead in scaffolding, in building up different services and set up the communication channel between them. You can very quickly build your solution and deploy it to production. However, over time, the productivity tends to drop. And at a certain point, it will be not that easy to maintain. And from this chart, it's a bit extreme, but you can see that at some point it dropped to 0, which means that your monolith architecture, your monolith solution is such a big beast that's very hard to handle. And even to change a single piece requires a lot of time to test. So we see that as not maintainable anymore. And in comparison, the microservice architecture would start off with a lower development speed or productivity. What that means is you're going to have to set up a lot of cross-cutting services and boilerplates. And you need to work out the boundary between different services and development teams. But over time, the development speed is going to increase. But it's not going to be as quick as what Monolith is upfront, because you have to take care of a lot of services and the interactions between them. However, even over time, when your entire solution or your business domain has grown bigger and bigger, if you are following microservice architecture, it will always be maintainable, because we are only touching a smaller piece of your entire business domain. And if you've ever added a new or introduced a new business unit or added a new feature which is completely different from other piece in the domain, what you tend to do is you can create a new microservice. So you will still be maintainable. Now, we've looked at the development side and the deployment side. Let's look at how we connect them up using DevOps. Apparently, we want to exercise Agile methodology, and the benefits of using microservice is that it essentially can empower your Agile process, because every single service can be deployed flexibly, and we separate the deployment from release. You can deploy your service without having a big release, as what we do compared to the traditional monolith architecture. So that way, we can have a progressive release strategy in which we can have dark launch or feature flagging. So here is a small chart, or shows that what a toggle on and off and feature flagging means. So what that means is you can try to do launch some feature, but turning the feature on and off flexibly in your production environment, which dictates whether your end user is gonna have access to it. So the benefit of this technique is you can get early user telemetry and feedback from the end user without an official announcement that you've got any feature on. And this way, you can tweak your feature and give user a better experience. Can this be done on a monolith architecture? Yes, it can be done. You have your APIs, you can have toggle on and off on your APIs. However, with microservice, it's much easier because your feature sets tend to live on individual microservices if you've done the boundary between microservices clearly and properly. So we've looked at a bunch of benefits on microservice. What is the other dark side? So there are certain challenges. The biggest challenge I see in a microservice architecture is that you can easily fall into the trap, what we call micro-monolith. A big example here is you might have some shared function called, let's say, format date. We want to format a calendar date to a certain format that adapt to different culture. And that method can potentially be leveraged by a lot of places in your microservice, especially spread out across different microservices. You don't want to repeat yourself. This is one of the famous dry pattern we follow. So what you tend to do is that each of your service is going to reference that DLL. Now, if you made a change, of course, in this example, a date format is unlikely to be changed. But if we think about something big, maybe your authentication or your token generation process or whatever, if you make a change in that shared method, you have to at least test and make sure it works on all those references. And those microservices, although they sit on their own, they all depend on the same piece. This is what we call micro-monolith. So that way, although you have, from the outside, you see each service sits on its own and it has its own business domain and the boundary, but they all rely on a shared piece. This is bad. But sometimes it's hard to avoid. Then what we can do to improve this situation or to avoid the potential trap? What we should do is to package the shared code and publish them properly. As on .NET we have NuGet, on npm we have on Node.js we have npm, and whatever library your language has. And that way, if that shared library is been updated or patched, wherever it's published, we can properly version it. And all the dependent services can make their own decision whether they want to bump up the version number or they want to leave as is. And the library can give proper obsolete or deprecate signals or alerts to the dependent that, hey, you have to upgrade. And then it becomes the consumer, in our cases, each individual service's responsibility to make a decision and to do proper testing. The next challenge is about data. As I mentioned in one of the slides before, each microservice has to own its own data store. This is an important principle, but it brings problems. The biggest problem is the referencing data. So service A, take an online ordering system or online shopping site as an example. Your checkout process or the order process is very likely sits on its own microservice called order service. Let's call it order service. When it's checking out for a user, most of the time it's gonna need to reference some metadata from the user service, which owns the user data store. For instance, the user's, membership number and some other piece of data. And those data are very unlikely to change, and they are always need to be referenced by the order service. In this case, we can certainly file off a request or via some pub sub service to get some data from the other service. But what if the other service is done at the moment your primary service is trying to get a hold of the other service and get some data from it? One of the solutions is we can duplicate some data to different service. If that piece of data is very likely to be referenced often and is less likely to be updated. And here, by my statement, you can already tell the potential issue is the frequency the data is updated and what happened for stale data. That is something we need to watch out for. So, as a quick summary, as I explained, we can reference the external service directly, or in some sorts, either HTTP core or pub sub service on Azure has service bus, or we can try to duplicate the data. If you choose to duplicate the data, you need to be careful. Although data storage is cheap, storing the data doesn't seem to be an issue at all. But make sure the redundancy of the data or the change of the data doesn't affect your primary logic in the service. So, in a nutshell, the reliability of individual services need to be looked into and taken care of. So, we need a very clear domain boundary. This is, I see, the biggest challenge, and it requires a lot of domain expertise. So usually if we try to run a microservice architecture or microservice development team, the Scrum Master's or tech lead's job, responsibility is higher. You need to have a domain knowledge so that the life of your dev team members is simpler and easier, but the tech lead needs to take more consideration and thought into how you divide the boundary of the services. Now, let's look at some services. The primary piece that a microservice is composed of is API gateway. As I said before, it's a single point of entry of your microservice solution. You can think about it as a big middleware. If we're familiar with .NET, it's like a big middleware sits in front of your applications that every single request from external world need to go into, and it will get a response from. So we have a bunch of middleware that's every single request need to go through and tend to have some shared logic. Then we can group them into an API gateway. But API gateway does not only serve as middleware, it can also coordinate the external traffic. The simplest way of coordination is proxy. It's just offload the traffic as is to some subsequent service directly. Or you can do fan out, and together with load balancing approach in the individual services. Or it can orchestrate data or aggregate data from different services and return them in one go as a response payload. And sometimes we want to consider backend for front end, especially, for instance, we want to have some GraphQL API suite for our mobile apps. Here is an example of a shopping cart solution or online store solution. We have an API gateway and we have a bunch of services like order service, shipping service. They're all being coordinated and they're all being entered via the API gateway. Now, Ocelot is my favorite library to quick and easily build your API gateway. So first of all, it's very famous in .NET world. It's open source, of course. And what it essentially is it's a bunch of middlewares executed in a certain order. Of course, we can define it. So that way, a lot of cross-cutting concerns can be grouped into one service. Then if anything goes wrong, we can troubleshoot that API gateway service rather than digging into each individual service for cross-cutting concerns. And most of the time, authentication is a good example of a piece of cross-cutting concern. And it started to support WebSocket, which is good news. So you can not just build your APIs runs on HTTP protocol, HTTP or HTTPS protocol, but also you can let it run off your WebSocket connection. So you can have some real-time feature like real-time dashboard. Now, the way to add it is very simple. We just need to include the package. So you can see here. Also, it's currently on version 18. I checked this morning. And then, as usual, here this code snippet is based on .NET 6. And we can see we just need to add Ocelot's definition file, which is essentially a JSON file of different environments. So then you can programmatically load your Ocelot definition for different hosting environments. And in Program CS, and in .NET 6 we only have Program CS, whereas in the previous version we have the startup.cs. But basically, in your configuration, we add Ocelot, and then we want to use Ocelot. Now, a lot of developers like Swagger, which gives you an interface where you can observe your APIs from the definition perspective and what does the payload look like, etc. For Ocelot, we need to introduce a library called mlib.swagger for Ocelot. And then we just add Swagger as usual. We add the swashbuckle library, and we just can configure the Ocelot in the code snippet as the code snippet that I show here. But what's more important is if we want to introduce some sort of authentication onto your Ocelot definition or onto your API gateway, what you need to do is you can bring in your authentication schema. In this case, in the code snippet you see on the screen, we're using the JW token schema. And mind you, the Ocelot is no different from a normal .NET web app. So you can bring in the your schema, either JWT or cookie schema easily. And here is an example of a typical Ocelot definition file. And in each segment of the definition, we'll see that we have a template definition, which would coordinate the traffic to the subsequent service. Here, my subsequent service sits on a port 5001 on my local host. Apparently, this Ocelot should be ocelot.development.json. And it runs off HTTP protocol, and it will hit this route. And here it supports wildcard, which is great. Or you can be more specific, like /hello world. Now, what does upstream pass template means is that which endpoint or which route the external world, the client app, is going to consume. In this case, we have a definition. I like to keep the upstream template and downstream template the same because it's easier for troubleshooting. But you don't have to. You can wrap up some complexities of your downstream services and have a different representation of your upstream route. And you need to declare the method it supports. And now, if we want to say, hey, this endpoint requires authentication, we just need to add a segment of authentication options with a key provider, with a provider key. And here, the Swagger key is how the Ocelot library or the Ocelot for Swagger library is going to amalgamate the Swagger definition files to one single point and serve it in front of user, which I'll show you later. Now, there's a technique called header transform, and the benefit of it is we don't want to repeat ourselves. That's the biggest principle of having some API gateway of some sort, apart from the other comprehensive features like coordination, fan out, etc. So, for instance, let's take authentication as an example. What we want to avoid is we only want to authenticate once at some point. So, and when the traffic comes to the downstream microservice, we don't want to authenticate again. However, you might have the question, now, what if my endpoint relies on some parameters that need to be extracted out from your cookie or JWT token? What are we going to do? Because you don't want to authenticate again. Now, Ocelot offers this cool feature called header transform. You can extract the claims out from for instance, your JWT token and forward them to the subsequent service. And your subsequent service just merely consume these parameters as normal headers. So that's why when you do testing or when you build your microservices on your local machine or in a test environment, you can test those services directly without any hassle in setting up the authentication story. Now, we've talked about Swagger, and on the UI, we might have an authentication button that we can add our authentication, our JWT token onto, and so that we can call the Swagger endpoint via the UI. This configuration seems a little bit complex, but I'll show you the UI in action soon. And I have uploaded the code onto my repository. You can have access to it later. All right, so Ocelot is apparently my favorite because it's simple and easy, but it is not the only choice. And is it the best choice? It depends. But let's look at some other options. So first of all, we have other open source tools such as Envoy. And actually, Envoy has been updated on, Microsoft has updated its document repository and the famous online shopping site example to use Envoy from using Ocelot. So I'll definitely check it out to see what benefit it brings. And the other is Yap. Yap has recently come out. Microsoft want to advocate it as a reverse proxy solution. Apparently, I haven't checked it out in details. So but I list it here because it's a great alternative I see. Now, we can build our own API gateway from ground up. We can also leverage PaaS service on Azure. First one is my favorite, is API management. It has a lot of great features out of the box, and apparently it's a platform as a service, so you don't need to worry about the reliability, the hosting, and all that. You can offload that to Azure. So you can focus on building all your template, your upstream template, downstream template, your authentication, your cookie affinity, your rate limiting, and etc. You don't need to worry about what if the API gateway goes down. Of course, it's like other PaaS service. It can have problem, but it runs on Azure's SLA, so you can trust it. And then another alternative is application gateway. It's often used with your Kubernetes cluster. Basically, I don't use it with other type of hosting model for the subsequent services. So here we have Kubernetes. You can use application gateway, or you can have other type of ingress controller such as Ninjax. Again, you have to build your own API gateway if you choose to use Ninjax. All right, so VNet. We don't have to have VNet, but I usually like to place some sort of protection around my microservices so that we not only have the single point of entry and the external visitors cannot easily break into my house from the side window. It protects my microservices, of course. And it can help to expose the API gateway and enclose other bits and pieces that is supposed to sit behind the API gateway. So it ensures the traffic between the microservices runs on the backbone network instead of some publicly accessible internet. So we need to make sure the services sitting in the microservice architecture can communicate with each other. These are the options. There is a pattern called Saga pattern, and it has two variations. First is choreography. What that means is that it's like a team of dancers. Basically, when one service has done its job, basically, or it has completed its task, the other service is going to react to it while getting some events through some channel. So we can think about one dancer has done his or her movement, and another dancer would react to it. So this way, the events are trained up, and the services react after each other, and eventually they're gonna complete some task. In comparison, there's the other one called orchestration. So from the wording, we can tell that the core difference is that orchestration has a single pipeline which serves as a controller or a controlling station that sends off requests to different services via some messaging broker, and collects response and coordinates the logic flow. Now, we want to leverage event sourcing if we want to implement Saga pattern properly or in a good way. The reason is, if anything happens out of order or anything goes wrong in the, for instance, if you follow the choreography pattern, if anything goes wrong in the middle of, so for instance, one service has finished its job, but the other one is supposed to finish its job but doesn't. Well, we want a better way to trace the events and a better way potentially to rewind or replay a certain event. And there has to be some sort of pops-up messaging system to support this pattern, so the message can easily be communicated. We don't want to call other services directly. And sometimes notification need to be added. But we need to be careful that we want up-to-date data. Also, when some dependent service goes wrong, we don't want the main service go down as a consequence. So there has to be a balance between whether the data is up to date or not versus whether the other service would affect the other service broken down would affect the primary service or not. All right, so we've understood different pieces that can make up our microservice. Let's look at Azure what we can do. First of all, we have VNet, as I mentioned before, and we want to leverage Key Vault, which can store our keys and secrets. And there's recently application configuration service as well, which is not listed here, but it compensates the Key Vault very well. We want to leverage managed identity so that we don't have to set up the authentication for different services on Azure. And we've talked about pub/sub service or messaging system. There are different offerings on Azure. There's service bus. There's the simplest storage account queue, or there's event hub, event grid, etc. Now, we've looked at the component here, different components that can together make up our microservice architecture. Here is a simplified diagram that shows you how we put them up. As we can see, we have our API gateway sitting here. If your API gateway supports WebSocket, that's great. If it doesn't, the alternative to build up your real-time side of communication is about something called Signal service. And you can connect Signal service on Azure together with your serverless hub on Azure Function. And I like to protect my microservices, as I mentioned before, with a VNet. And the cross-service communication is achieved via some pub/sub service. And the most important principle is each microservice should have its own data store. The data store can be anything pretty much, like could be a schema in a SQL server up to a Cosmos or a whole SQL database or even some Redis cache. And our API gateway or backend for frontend should be able to support different types of frontends. Here I have a Vue app or Electron app or native mobile app, etc. All right. Next up, most exciting part, I have prepared a demo. Let me bring up the code. All right. First of all, when we look at a microservice solution, the first thing we're going to look at is what are the services or resources we're going to create. Here, we love Azure, so we're going to use Azure to deploy our microservice solution. I have a Bicep app, Bicep template. Bicep is a language which is sort of like a superset of ARM template offered by Azure. I love it. I love to train my Bicep or ARM on Gym and in my VS Code as well. So a great feature VS Code has offered is an extension which can help you to code a Bicep visualizer. So if we open it up, and we make this smaller and make this bigger. Maybe let's just make it bigger and zoom in a bit. I think I can close it. Yes, I can. It gives you a way to visualize the services you're going to create on Azure. And in our case, let's make it bigger. First of all, we have our API gateway that we want to service as a web app. Now, my API gateway has got some special configurations, which I'll show you in a bit on Azure Portal. But essentially, we have added to a VNet. You might be wondering why the other microservices are not added to the VNet, because for the sake of this demo, I want to show you how we can configure that on Azure Portal. But basically, the other services need to have some sort of service connection or access policy to protect them from being accessed by public traffic, only allowing the traffic within the VNet to visit. If we look at individual microservices, what we can see is that they pretty much just sit on its own. Here, I haven't added the data store, but if we are to add any data store, each microservice should talk to its own data store rather than talking to other services' data store. Here we have a slot deployment for each services, which is not part of today's topic. You can simply focus on these services and the interactions between them. We can see that we have cross-cutting services. They all host on the same app service plan. But if need be, they can be hosted on different app service plan or use some different hosting models such as ACI or Kubernetes, which makes it easier for scaling. And we want to inject the logs into the same app inside and with its own log analytics space. Okay, so now we've had a look at the infrastructure. Let's look at some code. In this code example, I've got an API gateway, which is a .NET app. And I've got a Docker file. I'll just quickly show you. We build the app and containerize it. Not much difference from other containerized app. So what we have here, as I showed you on the slides before, in the program.cs file, this is .NET 6, we add the Ocelot definition according to the environments respectively. And we add authentication to the API gateway with the schema of our preference. And we want to add Ocelot. We want to add Swagger for Ocelot. And some other configurations before we run the app. Now, if we look at individual services, we added a Swagger generation definition and adding the authentication schema, but we are not adding the JWT schema as what we added to the API gateway again, because we introduced the claim transformation or header transform process on the Ocelot definition. So we can use the header directly. If we look at the controller, we can see that I have got a piece of code which shows you the login process, and in which, again, this is not a very clean architecture. We should probably wrap this to a separate class. But what we are doing here is we are issuing a JWT token with some special claim. And we want to consume the claim in subsequent service without validating the JWT token again. Oh, sorry, misclicked. Special claim. As we can see that we've added a new claim here, and then we have the claim transformation process added to the subsequent service. Now, the other service we have is, I've got a test here, and apparently we want to hook this up to your DevOps process, which I'll show you in action a bit. On the other service, we can see that we can enable authentication if the authentication definition is configured and ready to use. Now, we've got all the microservices, and let's see how we can run them locally. Since we are using Docker, I have a Docker compose file, which apparently I'm referencing the image directly. I pre-built them to simplify this demo. Just show you, I built these Docker images beforehand, and we can spin them up in a programmatic way using Docker Compose. All right, let's run them. Now we can see that our service 1 and service 2 have been spun up. And in theory, it should show up here. There we go. So 2 services have been spun up. The reason why I'm not adding the API gateway to this Docker Compose is because I want to demo to you how it works behind the hood. It's easier if we spin that up on a separate screen, which I'll show you in a bit. But if we try to observe each individual service on the browser, we can see that we have a nice and cool Swagger screen. And we can see that we have a service 1 with authentication endpoint. We can try it out, we can execute. It generates some response. All right, so the reason why I call it service 1 with auth is that later I want to show you that without proper authentication, you won't be able to call it via API gateway. Now, we've got both services up and running. Let's close this. Let's have another console here and run our API gateway. Now, to run API gateway, we need to specify the ports. And these ports need to be consistent. Let me make this screen bigger. Just give me a sec. That's much bigger. Let me just clean up my window. All right, these ports need to be consistent with our Ocelot definition. So if we flip back to the Ocelot definition, what we will find is, for instance, let's take development as an example. The Ocelot definition JSON file has a configuration called global configuration, and on it, it has a base URL. This URL is what the external world sees your service runs on. So you need to make sure that your service is spun up on these ports and on this host. So if we look at the prod Ocelot, what we'll see is I define the base URL as an URL given by Azure Web App. So now let's come back to my console and run it on port 5000. Great, it's up and running. Let's hit it. We can see that when we hit it, because I haven't configured it to serve static files, so apparently it's not going to find anything on the default route. But if we go to /Swagger, we'll see the Swagger definition. Oh, it's by default hooked to API 1. But let's just come back. It has its own Swagger definition. And I have a health track endpoint. I just click on it to make sure that it works. Now, great. Now, from the API gateway's Swagger definition, we can also observe what's going on with the other services. Service A and service B. It's nice and clear. And what's happening behind the hood is, if you come back to service A, you'll see that it's trying to fetch a service A's Swagger definition file from this endpoint. Now, if we look at the console, we will see that we are getting the actual Swagger file from port 5001. That's where I define my service 1 runs upon. If you look at the Docker Compose file, we can see that I say, hey, for service A, because .NET by default uses port 80, so I'm mapping 5001 to 80 for service 1, and for service 2, we map 5002 to port 80. You can see that even for the Swagger file, you can tell that the API gateway is coordinating your traffic as what we defined in the Ocelot file. And this is great. And this is the heart of how an API gateway works. So that from external world, you only interact with a suite of endpoint which is defined in the upstream template, whereas you can have your own flexibility in the subsequent services. Now, as I said before, if we try to, let me just close this. If we try to call any endpoint that requires authentication, I think I need to flip back to the code to show you the definition file. So here, if we look at this definition again, for service 1 with auth endpoint, we wanted to have authentication option with a bearer token. What this means is that if any API call lack of a bearer token or has an invalid or expired bearer token, it's not going to allow us to go past the authentication process. Let's verify it. Remember, when we call service 1's endpoint separately, we were able to call this endpoint, get some response. Now let's try to call it again. Boom, unauthorized. Just for the sake of comparison, or before that, let me show you what's actually happening. So from the verbose output from the API gateway, what we can see that this route is an authenticated route. Authentication is required. However, the client hasn't supplied a proper authentication token, so you get 401. Now, just in comparison, let me try to bring the service 1 up by itself and repeat it, what I did before. We could call it because there's no authentication that's being enforced with the individual service. The authentication is done on the API level, on the API gateway level. All right, so if we flip back to the API gateway, and let's try to log in. Create some username, password. You probably should hash the password and have some validation, but for the simplicity, I just do it quick and easy. Now, we've got our JWT token. And if we copy our JWT token, before we jump on the authentication bit, I just want to show you that it's a proper JWT token with the information we need. So this is generated as what we expected. And if we come back to here, this is port 5000, which is our API gateway. If we put it in here and click authorize, click close. And this time, if we try to call this again, mind you, it used to be 401. Now this time, if we try to call it, oh, unauthorized again. What's going on? All right, so the code that's used to generate the auth key may be different from the one that we use to generate the auth key. So we are trying to read the auth key from this service. This auth key, while as we try to get the different auth secret key for API gateway. If they are different, then it's not going to work. Look, it's live demo. Anything can go wrong. But I have a running version on Azure, which I can show you how it works. So if you look at Azure, and we look at this is on Azure, I'll show you how it's deployed in a bit. All right, it's unauthorized. Once we log in, we generated a response, copy. Great, it's authenticated. I apologize that I haven't got the auth key aligned with the API gateway and the service. But as you can see that on Azure, I'm hitting only the API gateway. With the proper authentication process, we can hit the subsequent service with the authentication defined in the API gateway's Ocelot definition. Now, let's look at how we deploy our service to Azure. I have a DevOps. We have a Azure DevOps project, which is on here. And I'm not going to dig into details, but basically, we have an API gateway and a couple of microservices. If you look at the pipeline, what we did, this was the last run I triggered. It has multiple stages. We check out code. And we haven't done anything in the build process, but we can potentially add some, for instance, .NET test. But basically, in the publish process, I build our Docker image, which I think is better. I'll show you the code here. Here, there we go. Let's make this bigger. We connect to our Azure Container Registry, and then we deploy to the staging slot. You don't have to have a slot deployment. You can just deploy to the main app. But if we use the slot deployment, we can swap the slots if we need to, or manually swap the slots. Now, I showed you that I have a test project on one of the microservices. The way I like to structure my folders is we have service one, and then we have the test next to it. And on our pipeline, what we can do is we can check out the code, and we can run our test and publish it using something called Kubernetes, which will give us a very good visualized way of reviewing our test report. And then if everything goes well, apparently you can choose to hook up your test with your pull request process. And if everything goes well, we go to the release stage where we build our image and deploy. Now, the test report would look like this. If you look at service one, where we have add some test, we can see that once we publish the test, we'll see a test code coverage tab appear here. And if we click on it, we'll see that, oh, I've got some test. It covers only 1%, which is pretty bad. But basically, once we get a visualized way of seeing our report, we can aim at improving the coverage. And now, We've deployed to Azure by running our pipeline. What we want to do next is to protect our services. All right, let's jump back to Azure. So as we can see, I've got a resource group where I provision all the resources as what I defined on my bicep template. We have a VNet, and the way I like to set it up is to add the API gateway to the VNet, which I believe I already did. So what I've done was go to the networking tab. From the bicep definition, you can see that it's already been configured to coordinate the outbound traffic running on this VNet. So the configuration is super simple. If you disconnect it and reconnect again, you will see the same layout, basically. You just choose which VNet the outbound traffic goes on. Now, we have defined the outbound traffic going out from the API gateway. Then how can we make sure that the external world cannot call my microservice directly, like what I did on my local machine? There are a couple of ways. One simplest way is to create an access restriction on the subsequent service. So what it means is, by default, we're going to allow, Azure is going to allow all public traffic to hit the service, to hit the host. But we can add a rule that we only allow the traffic from certain sources to hit. And one of the sources is VNet. So if you try to add a new rule, you can see that here we can choose different types of source. You can either give it an IP address or a service tag or VNet. So we are defining it. I have already got a rule here. We choose the VNet, which means that we only want the traffic going out from the VNet to hit our service 1. And all the rest should be banned. Now, how that look in action is, before I show you that, let's just have as a very quick comparison. Service 2 doesn't have any access restrictions at the moment. So what I'll do is I'll hit service 2. We've got service 2, we have several endpoints. Nice. And let's go to service 1 and see what happened. So in theory, if the access policy is looking after our service, what I'll get is forbidden. So what this means is that Azure will block any traffic from hitting the endpoint except the traffic from the VNet. So we've already saw it, but let me just bring that up again. From our API gateway, we are hitting service 1's endpoint. We can hit them easily, as we do. So we go to this service B, just make sure that we can hit it. And we go back to service A, we can hit it. Now, just to show you as sort of like a proof of concepts, let's go to service 2 and enable the access policy and see all public traffic being stopped. So this is service 2 or service B. I use this term interchangeably. Let's go to networking. Let's add an access restriction. Add a rule. So you can see here, by default, it's not configured. It allows any resource from hitting your service. Let's add a rule to only allow, say, allow VNet. And we'll need to give it a priority, just 300, that's what he suggests. Allow traffic from VNet. I always give is a good description for the next person to maintain. So let's choose VNet. And I've got multiple VNet, but for our demo, let's just use the VNet we created. All right, let's add the rule. It's going to take a while. Just be a little bit patient. While it's doing the configuration, let's come back and have a very quick look on the resources we created. We have a container registry, which from the DevOps, we build and provision our, tag our images. If we have a quick look of the repositories it's got, you'll see that we've got 3 repositories sitting on the Azure Container Registry, and they have their own tag. And the way they are connected or they are served from the app is via something called deployment center. So here you can see that we've configured our app to have a source from container registry via the managed identity. And since we are leveraging a managed identity, we need to assign some role to the app. And if we look at the bicep template I've got, I can show you what I've got. So for instance, this app, we want to say, hey, you need to have a service, you need to have a role, which is the global admin. And mind you, this global admin role can only be assigned once to a service. Then this is how you do it. You do a role assignment. This can also be done by Azure CLI, by the way. But if you want to do it in Bicep, you can say, I want to assign a service principal with this role definition. And that way, the app service can reference and pull images from the container registry easily. If you don't this, you can choose admin credentials, but that would create a couple of additional configurations. For instance, your container registry's username and password into the configurations of your application. From the notifications now, we can see that the rule is done. So if we remember what we saw from service 1, which already had the rule, now for service 2, it should be banned. Let's see. Boom, we got 403. So our services are very secure. If we try to hit service 2 from the API gateway, this is service 2, let me refresh it, 403. Now, but from here, if we try to hit service B, just in case, we can see that it takes some time to load. A little bit slow. Let me try to refresh. There we go. We still can hit the service B's endpoint from the API gateway. So here we can see that how easy it is for you to set up a VNet and protect your microservices. And you can still try to use and reference some key information of your claims from extract out from your application gateway. Sorry, your API gateway. All right, we've done our demo. And from it, you can see how quick and easy it is with spin up a API gateway in Ocelot and a couple of microservices and get them running on the local machine. And I show you how the external traffic is being coordinated by the Ocelot and hit the individual services separately. As a quick summary, today, first of all, we've at a very high level looked at monolith versus microservice. And we've understood what is the monolith. It's not the evil, but it's sometimes can be good, especially for greenfield projects. But microservice has its own advantage as well. And then we had a deep dive into microservice, and we understood the key components and the bits and pieces we need to look out for and the potential trap we can fall into. And then we've looked at microservice on Azure, and while the demo, the second half of the demo, we've seen how we provision services on Azure and how we deploy our microservices onto Azure in a containerized way. And that's what the demo is about, but we briefly touched on the DevOps side and also the VNet configuration onto Azure. All right, here are my references. If you've already forgotten about what I did with my code, don't you worry. There is the first link, which is to the repository on Azure DevOps. I've got all my code for you. Try to clone it and spin it up on your local machine. And if you like, you can raise pull requests to make the template better. And I want to use it as a good starting point of building your future microservices. And the second one has the information you need and potentially the knowledge you need to back up your design and your reason to choose microservice. And there's the third link, which is the rules to buy a better microservice on SSW Rules. If you've got any feedback or if you've got opinions, you're welcome to let me know by filling in the survey. Please scan it. With that, thank you very much. I'll see you next time.
All right, thanks, Pat. That was awesome. I have a bunch of questions that people have been seeing through, so I might ask you. So, all right, I'll start from the beginning here. There's several people here. So how's this? Compared with a monolith, is it much more difficult to manage the infrastructure deployment of the microservices, the deployment piece?
Thanks for the question. So the question is about basically the infrastructure side of microservice, whether it's much more difficult than managing a monolith infrastructure, basically. That's a very good question. As I said in the initial few slides, for the monoliths, you only need to worry about one. Apparently, you're going to have the staging or dev environment, but essentially, once you've deployed, you only need to worry about one production environment. Whereas in comparison, for microservice, you need to look after each individual service's hosting environment. And the simple answer is yes. It's you need more effort and it's more cumbersome to look after your microservices infrastructure. However, as we also saw on my demo, I've got a bicep app, which basically can have all your definitions for the services you're going to provision to host your microservice. So if you've done it properly in a modular way, you see on the bicep app, I don't have to repeat myself. For some of the microservices, the infrastructure and the configurations are similar. We can repeat that. Basically, infrastructure as code can be on clean architecture as well. Right. So if you've done it properly, it can reduce the amount of effort and the potential mistakes that you're going to make.
Right. Is it a one-time pain, or does it keep coming back? Like once you've set it up, is it mostly done? Is it one of the painful areas, or there's plenty of other areas that are more painful?
Yeah. Yes, it could be a painful area, especially thinking about production. If anything goes wrong, you need to dig into potentially multiple hosting environments. Right. That is true. Okay. Although it brings flexibility that if individual piece goes wrong, we can turn that piece off. As you mentioned in your news session, that we had this situation before that the microservices goes wrong and we turn an individual service off and it doesn't affect the other parts, but it unblock user or it dismissed or it ignored all the alert fired off or the errors fired off from that service.
So just to be clear, when you're saying when the microservice goes wrong, you're talking about a service that is pegged at 100% and causing problems.
That's right.
Yeah.
So from user perspective, they wouldn't know or understand that an application I'm using is composed of different bits and pieces. From their eyes, they say, something goes wrong. But from engineer's perspective, we've turned that piece off. It doesn't affect other pieces from functioning and interacting, which is great.
Okay. So I got another one here. So how do you find managing changes in one microservice and it breaking another microservice? Like obviously developers hate touching one thing and it breaks another thing that they don't expect. That happens more within the microservice architecture, right?
So the question is about whether a change in one microservice can potentially affect other piece and what we should do. I would say it happens quite often because especially when your microservices interact with each other a lot. So what we do on our projects is that we'll try to have proper API versioning on our service so that we don't introduce breaking change, or if we introduce breaking change, we mark it or we bump up the version so the consumers can make its own. Here, consumer is another service which relies on this services API. Can make its own decisions on whether you want to reference the new one, taking the risk, or you want to stay on the old version of API, which guarantees to work or guaranteed to some sort. But apparently, if there's big breaking change, which changes data schema and a bunch of configurations, then certainly it's going to happen.
Right.
So I would say that's the pain for doing the microservice.
So the next question is about splitting things up. Do you normally split, do you find most services, like a microservice, usually maps to a database in most cases? Or that's not common?
So mapping a microservice to its own data store is important. As I mentioned on the presentation, this is the key principle of a microservice architecture. So this is more from an integration test perspective. For one individual microservice, you test with its the database setup and tear down process. If you want to have cross-service data reference, you call the other service rather than touching the other service's data store. But as I also mentioned, there is another case where a database is not equivalent to a data store. So one microservice can potentially own, say, 2 tables of a database, and the other service can own the other 3 tables. But these 2 or 3 tables need to be organized in some way. For instance, a view or a schema. Yeah.
Okay. All right. What's the golden rule to prevent a house of cards scenario when doing my first microservices?
Can I beg your pardon or rephrase what is a house of cards mean?
A house of cards. A house of cards is when you have you build something and it's fragile. You have a number of cards and you build these cards, and one puff of wind makes it fall over. You know, how do you make it more resilient?
That's a very good question. So especially when you've got something that's a small piece can affect a whole lot. But in my understanding, to that question, it's more like a monolith architecture, so that it's tightly coupled. A small piece in your construction, let's say in your construction, can potentially affect a whole lot if it's been broken. With microservice, we tend to have a loosely coupled architecture, so that one card in your whole construction should not affect the other parts if it's broken. And the interactions between them need to be via some sort of pops up or some channel. So if one service is dead, the other service gets some sort of alert, but they can also set up their own caching or recovery process, or there's a pattern called circuit breaker pattern. Now, when the service is back online, we slowly ramp up the traffic. So there are certain ways to mitigate
it. Right. Okay. All right. So we know about functionality and how you can break up a large monolith application into smaller pieces. But what about a startup and just thinking of the team size of, say, 4 or 5 people? Would you, as a startup, choose a Microsoft Services approach from the beginning?
The question is for startup or for a dev team composed of a small number of developers, whether we should choose monoliths over microservices or the other way around. There's no best answer for this one off the top of my head.
Right.
It's a case-by-case thing. So basically, my rule of thumb is if you can be a startup, but you might have a clear idea of a certain business domain and that you're gonna touch on or grow into, then you can have several services, but don't try to over-engineer or like start off building a lot of things in one go. But start simple. If you are not clear about where you are going to hit in 3 or 5 months, start with a monolith approach.
Good. All right. I thought you weren't going to get there. Yes. I've been asked this question a lot of times as well. Usually it's the biggest organizations that do microservices well. Most small companies build successful applications in a monolith approach. Now, obviously, you might have, good scenarios where you do need to do that, but most of the time you can get through with a monolith. Here we go. All right, I think that you answered this, but I'll ask it anyway. For organizations that have hit the unmaintainable monolith state, how do you recommend that they approach migrating to the microservices approach?
When we get a giant bit, how we can manage it or how we can migrate to a better tech stack or a better architecture is a very good question. The way we do it is, as I mentioned before, is the strangler fig pattern. We don't want to have a big bang approach where you spend, I don't know, months or years to build a new version of the app or to cut it to smaller pieces and then make sure that everything works again. But what we want to do instead is that we start building smaller bits and pieces which can potentially replace a component of the big giant, and we spin it up and let it run in production. And in parallel, we have this big giant running still, but which somehow, and this is a good way of using API Gateway, we route the incoming traffic which need to hit this piece of the big giant to the new services that we've built. So gradually, once during the process of building the microservice, we can accumulate our knowledge and we have a better understanding of the business domain. Then we can gradually build different microservices or try to enlarge the microservice we've built.
Right. Okay. Which is the simplest tech stack you would recommend for someone who wants to try it and play with microservices for the first time?
What is the tech stack to recommend to build a microservice for the first time? That is also a very good question. I would say in my demo, I've showed you the simplest approach I can think of. If we are a .NET developer, .NET 6 web app is your choice to build your web apps. And you can choose to use a Docker to containerize your app, or you can just deploy them as a web app. And for API Gateway, Ocelot is my favorite on .NET Word. And if you want to use some more or complex or feature-rich tools, I've also introduced several alternatives such as API management on Azure or Envoy as another open source tool. But apparently, the more feature a library or a service offers, the more complexity it brings in. So if you ask for the simplest way to get started on .NET, I would choose Ocelot with .NET 6.
Okay, all right. Related question. Hey, Patrick, what's your favorite, coolest feature for implementing microservices in Ocelot?
The question is my favorite, the price, the feature I like most offered by Ocelot. I think it's the simplicity in the definition. It has the JSON file. You can have different environments. You can have JSON files for different environments, and you can load the definition wherever you need to. And this way, we can have the definition in our code, in our source control, so that when anything goes wrong, we can easily troubleshoot. Apparently, as a comparison, like on API management, you can export API management, or you can use Bicep or ARM template or Pulumi or any infrastructure as code to manage it. But we're all developers. We're familiar with JSON, and we have it on the same code, same project, same folder. It's easier to manage.
Okay.
I would say that's
all right.
my favorite.
I think you've answered this, but why would you use Ocelot over a PaaS offering like API Gateway, API management from Microsoft?
Why would I use Ocelot over the other PaaS offering? I would say for the simplicity. It's easy to get started. And we don't have to stick with it all the time. When the situation changes, or we want to have a more reliable, a more feature-rich solution, then we can choose to use PaaS offering. I'm not against using those PaaS offerings. It's just to help us to get started.
Right. Okay. If I implemented an API facade with Ocelot, would that be a good start for implementing the Strangler Fig pattern?
To implement the Strangler Fig pattern, whether you use Ocelot is a good choice, is a good question. I think so. I would think so. Unless you have a lot of requirements from the middleware perspective that Ocelot doesn't support. For instance, you might want to transform an array of claims out from Ocelot as an array of headers to subsequent service. That I don't think that feature is supported by Ocelot out of the box. You can certainly implement custom code as a middleware, but until we reach that complexity of a requirement, I would say Ocelot is not a bad choice.
Right. Okay. These questions are coming thick and fast. I might ask one more. Let's make this the last one.
Sure.
Question. Ocelot as an API gateway works super well when all your backend services are available. What lessons can you share about how Ocelot handles when backend services are temporarily down? Very good question. What we can do to handle or to mitigate when any subsequent service is temporarily unavailable is very challenging. And that also reflects the example you brought up at the news session that's on production, what happened. So we used a very simple approach that if any service become unavailable, show in file 3 or something, we just sort of like from the response perspective, we show the end user a message so that front end or any consumer can take it and bypass it. That's a simple approach. But the proper way to do this is that we need to introduce some caching mechanism, and that's line up with the circuit break pattern, that if anything goes wrong, we still want some sort of cached response to be returned to front end. But also there's a risk. I'm going crazy.
Yeah.
Refresh, it's still showing me the wrong data.
That's right. There's a challenge coming with it. So,
a UI little trigger that just says, it's a bit stale. Yeah, it might do the job. All right. Thank you, Patrick. Thank you so much for putting such a nice talk together about such a complex topic. It was fantastic. And I hope you all enjoyed it. Sorry we didn't answer every single one of your questions. I know there's a popular topic, but you will see a great talk next month. And this is Adam Cogan signing off for SSW TV.